My name is Kenneth Chang, and I will be presenting my lab report for Physics 2, Lab 1, Charge Tapes. So the purpose of this lab was to create a temporary charge on clear tape, observe how they interact with each other and other objects to determine their charges and excess charge, create a computational model via glow script, and the main results that we found were the tapes became positively charged, and the electric charge was 9.33 times 10 to the negative 9 coulombs, and the tape was deficient by 5.83 times 10 to the 10 electrons. So the fundamental physics principles that we used were Coulomb's law, which we used to calculate the electric force of the tapes, and Newton's second law, which we used to set force of gravity equal to electric force. So some assumptions we made were that each piece of tape was a point charge. We neglected air resistance, and we assumed that the pieces of tape were equal in charge. So going on to experiment in the system, we tape B was the system. The surroundings were tape A, table, and objects holding the system, like hands or the books we used to hold it up. Initial conditions were two neutral pieces of tapes, the mass of tapes and the length. So for the procedure, we stuck a neutral tape onto the table. We then created charge tapes by sticking them onto the base tape and rapidly removing them. We then hung the tapes off the table and we brought objects in close proximity to see if they would repel or attract them. And then in part B, we prop tape B up on an elevated surface and then we placed tape A underneath tape B to see if they would repel and we measured the distance. So some possible errors that we didn't account for in the experiment were the humidity of the air and touching the tape. So in our calculations, we calculate for the force of gravity by doing mass times gravity. We then set the force of gravity equal to the electric force. We then use Coulomb's law to calculate the charge, and the charge we got was 9.338 times 10 to the negative 9. We also found that electrons, the tape had electron deficiency, and we also calculated the number of atoms by finding the area of tape divided by the area of an atom. And we measured the distance between the tapes using a ruler. So the mass that we calculated was 2 times 10 to negative 4 kilograms. The distance was 0.02 meters between the tapes, and the charge was 9.338 times 10 to the negative 9 coulombs. The electron deficiency was 5.835 times 10 to the 10th electrons. The number of atoms on the tape were 4 times 10 to the 17th atoms, and the ratio of atoms to electrons was 6.853 times 10 to the 6 atoms for every one electron. Moving on to the computational model, I firstly defined my variables, and then I set the force of gravity equal to mass times gravity, and I set for electric force equal to the force of gravity, the magnitude of it specifically. I then coded the locations of particle A and particle B and plotted them as spheres. I then created a function used to calculate the electric force. I then did more calculations where I calculated the electron deficiency, the number of atoms on the tape, and the atom ratio. And the green arrow you see here is the force of gravity, and the yellow arrow you see here is the electric force of particle B. So what if electrons had positive charge and protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? So there wouldn't be much change in the experiment. If the tapes were both negatively charged, they would still repel each other. The electric charge of the tapes would just be negative, but have the same magnitude as before. So why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? So throughout the experiment, we noticed that the more we touched the tape, the observed reaction was weaker or there was no reaction. The tape would attract and repel objects, but they would also change the charge of the tape. It is important to handle them as little as possible to eliminate error and achieve the best results. Thank you, and that concludes my lab report.